So here we are on page 47. We're going to look for our extrema. So we're going to look for relative max, relative min, absolute max, and absolute min. So we're going to do two separate things. So two different processes for trying to do something that sounds kind of similar. You know, they're all max and min. So just to remind ourselves, all we're looking for is sign change, switching from increasing to decreasing or decreasing to increasing. Whereas absolute extrema, we're going to compare critical numbers to end behavior. So we're doing this graphically. If we were doing this algebraically, which we're about to, so some good review, relative max and min, you find critical numbers, you make a sign chart for your second step. Absolute max and min, we're going to find critical numbers, but in our second step, we're just going to compare the y values of our critical numbers to the end behavior. So if we're looking for relative max, I'm looking for critical numbers for both of these, first of all. They're the same first step, find critical numbers. So here's a critical number here, where the derivative would be 0 on the graph, and any soft peak would also have a derivative of 0. So this is more of a constant part that I would have a derivative of 0, and that's a soft peak. So there's my two critical numbers. That's my first step for both of them. And then to find relative extrema, I'm looking for a sign change. So I go from decreasing to decreasing to increasing. So you should be able to draw your conclusions about relative max and relative min. So this critical number switches from decreasing to decreasing. So it's neither. It's not a relative max or a relative min. And this critical number has a sign change from decreasing to increasing. So this one is a relative min, and I would say that's at the point 3, comma, negative, maybe 3.5. It's hard to say. So then as far as relative max, we had two critical numbers. One was a relative min, and the other one was neither. So there must not be a relative max for this graph. There's no critical number that goes from increasing to decreasing. So there's just none for that. Absolute extrema, we're going to look at these critical numbers again, but we're going to compare them to the end behavior to see if they're the absolute highest or absolute lowest. So for absolute max, neither of these critical numbers are relative max, but we would look at these and compare it to the end behavior. The left end behavior is going up to infinity, and the right end behavior is going up to infinity. So it's going up without bound. There's no relative or absolute max point where it definitely just stops. So this answer would be that there is none. It goes up without bound on both sides. Our absolute min, we're going to compare our critical numbers to our end behavior. Well, this critical number was a relative min, and I want to look at the end behavior and see if it's also the absolute min or not. So if we look at our left end behavior, it goes up, and our right end behavior goes up. There is no point that is ever going to be lower than this point here. We have found an absolute min. Our relative min of 3, comma, we called it negative 3.5. That is also our absolute min. So now we're going to flip back to where we were in the optimization section, and we're going to do that for that crazy graph on that page.